is going to equal, our formula for volume was 4 over 3 pi r cubed. So our steps would basically be divide both sides by pi, multiply by 3 over 4, and that comes out to what, like 900? And then we'd have to take the cube root of both sides. So that was the big problem on this one, is make sure you know how to do cube root in your calculator. Yeah? Can I also what?
Can you divide by 4 instead of multiplying by 3/4?
Yes. It's just multiplying by 3/4 is something you could do in your head. Dividing by 4/3 is a little bit more difficult, because then we have to do keep, change, flip. Do you get what I'm saying? What if you don't have a calculator, though? I'm just saying, using a reciprocal is a lot easier if you don't have a calculator handy. If you have a calculator, you can do whatever you want. But just know the other method, just in case we don't. And then we come up with R is about 9.7. We plugged in our calculator. Cool. Good. All right, the lesson goes pretty quick, so we're going to do the lesson first, and then we're going to go over homework questions. So if I forget to go over homework questions, someone yell at me. All right? Not too much, because then I cry, and it's just sad. All right, area of a sphere. Area of a sphere is 4 pi r squared. This is, once again, just a formula we need to memorize. But we don't have too many we need to memorize. Let's kind of go through the list that we have to have kind of memorized that are close to each other. Could someone tell me the basic idea behind the area of a cone? I'm sorry, not the area, the volume of a cone. How do I find the volume of a cone? Yeah.
Just like 1/3 base area times height.
1/3 base area times height. Same as a pyramid, right? What's the volume of a sphere? Denise? Pi r cubed. All right. And then the last one is 4 pi r squared. Here's the problem. We have lots of 4s and 3s in there. Your job is to keep it straight which one goes with which. So now we're talking about area of a sphere, which is 4 pi r. Well, these problems shouldn't be that hard now that we have that formula. So the first one is, well, our radius equals 3.5. So that means my surface area is going to equal, we said it's 4 times pi times my radius, which is 3.5, squared. That should come out to a nice even, 49? Yeah. That's going to come out to just 49 pi. And we were given inches, so let's go inches. And since it's area, it'd be inches squared. We have 49 pi inches squared. Once again, in my calculator, I do 3.5 squared, and then I multiply by 4. Probably the easiest way to do that. Am I correct that it's 49? Can someone confirm that?
Yeah.
Cool. Yeah.
Oh, no,
Okay, yeah. All right, our next one. What's the radius of our next one? Sam?
2.1.
It's 2.1. So make sure you recognize if you have a diameter or a radius. We were given a diameter, so we divide it by 2, and we get 2.1. That means our surface area is going to equal 4 times pi. My radius is 2.1 squared. So we do 2.1 squared times 4. Can someone give me that value? I think it's to the hundredths or something. I think we can get an exact answer. Yeah.
17.64.
17.64. Does it keep going?
No.
Oh, it's exactly 6.4, right?
Yeah.
All right. And that would be feet squared. So we didn't need to round it. It's exactly 17.64 feet squared. If I did say round to the 10th, we would just go 17.6. Yeah, sorry. What about the pi? Oh, I dropped the pi. Ooh, that's a good catch. That's a good catch. That's a point off, right? Got that point back. Make sure we keep our pi with all of our answers. That's what I was when I'm teaching the same thing all day. I drop it all the time. But you're not allowed to. I can, but you can't. All right. The whole reason I have this next one is because we need to talk about this as like a holistic point of view. We need to get the surface area of all of these parts. But here's the question. Would it make sense if I opened this up and found the area of the circle and then put it back on? In other words, I'm painting this. That's basically what our surface area is. It is what is all the area on the outside. You don't open this up, put a circle here, and find that area of the circle. So we're actually not finding any of the areas that are on the inside. So for instance, when I did a cylinder, when I asked for the surface area of the cylinder, I did the top circle, the bottom circle, and I did that rectangle that made up that cylinder, right? Do you remember doing that for surface area? Circle on top, circle on bottom, and we had a rectangle. We no longer have a circle on top and a circle on bottom, so that part's gone. Instead, we have a hemisphere on top. We have a cone on bottom, and we have a cylinder. So I just want this top portion of the cone, I just want this rectangle, and I just want this surface area of the cone. None of the circles that are inside of it. All right, just the outside areas. So that's exactly what we're going to do. Let's start from left to right. So from left, we have a hemisphere. So we have a shape that looks like this. That is my hemisphere. Well, the surface area, or the area of hemisphere, is going to be half the area of a sphere. So we're 1/2 the area of a sphere. Well, we said a sphere was 4 times pi r squared. Well, in this case, we'll have 4 pi times 6 squared. Well, that should equal 72 pi. So that top hemisphere is 72 pi. All right, the next thing we're going to look at is we'll go left to right. So let's do this rectangle. Remember, when you open up a cylinder, it just is a big old rectangle. We just got to remember something about that rectangle. So area of a rectangle is length times width. One of our measurements is 15. So let's put a 15 on here. What is the other measurement of that rectangle? Cece?
12 pi.
How did you get 12 pi?
Double the radius, and then it's a third one is pi.
Yeah. So other words of putting it, it's the circumference of that circle, right? 2 pi r. So it's 2 pi r, which would be 2 times pi times our radius. We said the radius was 6, which equals 12 pi. So what is the area of my rectangle? Who's got that for me? What is the area of my rectangle? Yeah, Leanne. 180 pi, right? All right, the last area is probably the hardest one we're going to get. I'm going to put kind of a... where's the best place to put this? We'll just put it up here. So remember, when you have a cone and you split it down the middle and you open it up, it still kind of has that cone shape. So once again, what I'm thinking about is cutting this down the middle and opening it up. It still has a cone shape, even though it's 2 dimensions. What I mean by that is it's going to look something like just a wider kind of thing like this. It's a flattened cone, just like that. When I open up a cone, it goes flat. Still kind of looks like a cone, but now it's 2 dimensions. What's the area of that? Who remembers the formula for the area of a cone? Not the volume, but the area, yeah. Pi RL. And the big thing is, I don't know if it was this class or a different class. I remember because it's like IRL. But it's pi r L. Where L is actually that length right there. Here's the problem. I don't know that length. That L is really this L right here. So it's the same L as here. But we can find it because I know the height of the cone was 12, and I know the radius is 6. So to get L, we would just do 6 squared plus 12 squared equals L squared. And if we work our way down, we're going to end up with 6 squared is 36, 144. That's going to be 200 equals L squared. Take the square root of both sides, and we're going to come up with L equals the square root of 180. 180. You're right? It was 180? I just did a little math too quick. And what does the square root of 180 simplify to? Because that looks pretty big. I know at least 4 goes into it. The very least 4 goes into it. Sam?
3 radical 10.
3 radical 10. Because 9 goes into it, right? It's 18 basically. Okay, 3 radical 10. So that means our area of this guy is going to equal pi times our radius, which said was 6. And now our L is that 3 radical 10. So this area is going to be 18 radical 10 pi. I think something, you know what? A bigger number went into it, actually. Yeah, so, that didn't simplify right. What is square root of 80, 180? It looked right. What is it actually? 6 radical 5. It looked right. You got me looking right. All right, so that should have been 6 radical 5 there, which would have been 36 radical 5 pi. That looks more like, is that correct? That one looks closer to what I remember. All right, now we're going to add as best we can. So I could straight up add 72 pi and 180 pi to give me 252 pi. Then we're going to add 36 square root of 5 pi. Now, although I can't directly add these two, I can factor out a pi out of both of them. So I could rewrite this as 252 plus 36 square root of 5. Put the pi outside. And we also have, what is it, centimeters? They didn't really give us any size, did they? No. So we'll just go units squared. Yes?
Do you have to factor out pi or no?
It's a good habit to get into. You're going to do a lot more in Algebra 2. It's not going to be a requirement in this class. So I'd be okay with that 252 pi plus 36 square root of 5 pi, but it's good to get in that habit of it. The earlier you start doing that kind of stuff, the easier it becomes when you have to do it. Yes, Cam?
When you use the pi times radius times length?
Pi times radius times whenever you have an area of a cone. That is that formula for area of a cone. Really quick, before we get to the homework questions, let's look at our actual homework. There's one problem I want to point out, is that it's number 3. Not that it's hard, just because I want to talk about it. So the radius of the hemisphere is 12 centimeters. What is the surface area? It says, do not forget about the great circle. So if you picture you have a hemisphere. So a sphere, surface area is 4 pi r squared. Hemisphere would be half that. But a hemisphere has a bottom on it. It has a circle on the bottom. So when you're calculating just a hemisphere all by itself, you have to do the hemisphere and the circle that's underneath it. That's where it says don't forget about the great circle. So the actual surface area of a hemisphere would include the top and the bottom, which is a circle. So it should be adding 2 things. Also, look at the very last question. The very last question says, I think it's number 10. It says approximate. So you will not have pi in your answer. You're actually going to plug in your calculator and get an actual decimal. Also, before we get to homework questions, I want to go over something that before people tune me out. Pay attention right now. Everyone, all eyes. For granted. Everyone, it comes up. Everyone, pay attention to what I'm about to say. This has to do with Google Classroom. Google Classroom just had an update, and for whatever reason, for anyone that ever prints out lessons, usually you just click on the lesson and there's a little print button. You can print it. For anyone that's ever done it, that print button for right now isn't working. It just says it's unable to print. To solve that, rather than clicking on the file in Google Classroom, just right-click on it like you would any link you want to open up another tab. You would just right-click on it and click Open in a new tab. That will allow you to print, download, do anything else with that file. Basically, when you just click on it, it opens within Google Classroom. If you right-click and open a new tab, it's just opening all by itself. All right, and that seems to fix the problem. So if you want to print something out, make sure you right-click on it and open it in a new tab. I hope you guys all pay attention to that because it might not happen today, it might not happen tomorrow, but maybe next week you need to print something out, and that will help you in case they don't have this thing fixed by then. All right. Questions from the homework. Let's do those now. Yeah, what do you got? Sure. What is 12? Is 12 the cylinder inscribed in a sphere?
Oh wait, no, I'm sorry. 13.
13. So we have a cylindrical glass that's 10 centimeters tall and 8 centimeters in diameter is filled with water 1 centimeters from the top. It says if a ball 4 centimeters in diameter is dropped in the glass, will the water overflow? So that means I need the volume of the cylinder. I need the volume of the water, and then I need the volume of the ball. Okay? And let's talk about why I need all of those. Yeah. Yeah, go ahead. So the volume of the cylinder would be how much water I can put in it. Okay? Now, the volume of the water, so we go up about this high. If I add the ball, it can't be bigger than the volume of the cylinder. Wait, does that make sense?
Yeah.
Did I lose? Okay. I felt like I didn't explain that well, but. So let's look at my work really quick. So I said the glass is just a cylinder. A cylinder's volume is base times height. The base of a cylinder is a circle, so I just did pi r squared times the height. That's how much water I could put in there. How much volume I could actually stuff in that glass is 160 pi, I guess, centimeters squared. Well, how much water is in it? Well, the water only goes up 9 centimeters because it says it's a centimeter from the top of the glass, right? So the only difference between the water and the cylinder is the height. So I just changed that 10 to a 9. That's now the height of the water. So the water has a volume of 144 pi. Well, the volume of a ball is 4/3 pi r cubed. And it says that the ball has a 4 centimeter diameter, so our radius is 2. So the volume of the ball is 4/3 pi, our radius is 2, cubed. And if I work that out, I end up being like 10.66666666 pi centimeters. Well, if I take this 10 2/3 pi plus the 144 pi, if that's greater than 160, it won't fit. If it's less than 160, then it will fit. And it turns out that is less than 160. Right? Because I'm adding, basically, even if I round that up to 11, I'd still be at 155 pi, even if I rounded it up. So we should be pretty safe. It won't overflow.
So if it were to overflow, it would just be more than 160?
It'd be more than 160. So let's say that ball turned out to be, let's say 20. Let's say that ball volume ended up being 20 pi. 20 pi plus 144 pi would be 164 pi. So that means it has 4 pi too much. It'd have to overflow 4 pi amount of water, volume of water. Other questions? Yeah. Sure. Number 12 is a cylinder inscribed into a sphere. Let's go ahead and take this picture. Okay, so we have a cylinder inscribed in a sphere. The height of the cylinder is 16 centimeters and the radius of the sphere is 10 centimeters. Find the volume between the sphere and the cylinder. So I just need sphere minus cylinder. Well, sphere is pretty easy. It gives us the radius of the sphere is 10. So my sphere is 4/3 pi r cubed. That is the volume of my sphere. Now I need the volume of the cylinder. Well, cylinder is pi r squared times its height. Well, the height isn't hard, that's 16. The hard part is the radius of that cylinder. Maybe I'll make that picture a little bigger. But if I'm looking basically two-dimensionally at this sphere, let's change that to black. So I'm looking at a sphere, like I have a bubble, right? And I'm looking straight at it, like this. It's going to look something like that with my cylinder inside of it. I'm looking sideways at it. Well, some important information I know the radius of the circle is 10 centimeters, right? So this is 10. Think about this red line I'm drawing is my radius, right? And the height of the cylinder is 16, which means this little right triangle I just created, remember I said if you ever know a radius, always do it from the center to the shape that's inside the corner. Well, this is just a 10. Got an 8 over here, and I have an R here.
So what is the R?
Our radius.
And is 10 also the radius?
10 is the radius of the circle.
Oh, but R.
R is the radius of my cylinder because
Yeah.
we need that circle that's on the bottom, and this would be the radius of that circle on the bottom, right? Does that make sense?
Yeah.
That this is always the radius of the sphere,
Yeah.
so even though that circle down here.
Okay.
So I'm actually finding that radius of that circle so I can do that pi r squared times the height.
Okay. The radius wouldn't be vertically.
The radius would not be vertical.
Okay. Because there's like no circle.
Well, remember what we're trying to find, right? We're trying to, let's see if I can superimpose this. Here is that circle that's on the bottom. It is our base area times our height that we're trying to find. So I need to know the radius of this circle here.
Oh, okay. Yeah.
There'd be no reason to come up with this distance because that wouldn't help me with base times height. My base is this circle, so I want the radius of this circle. So right, these are both the same r. So we just have to do r squared plus a squared equals 10 squared, or recognize that that is Pythagorean triple. If I divide by 2, it's actually, we'd have a 5, a 4, a 3, 4, 5. So this would be just 6. And that's where I got that 6 from.
So how do you know like the 8 is cut in half by that radius?
I drew it.
Oh, you do it. Be like that.
I'm the one that drew that. I drew this. This is the center of our circle. So it must be the center of our cylinder because our cylinder is inside of it. So this has to be, this 10 has to go to the center of our cylinder as well. So it must cut it in half. A center of a circle is going to be the center of any shape that's inside of it. Other questions? Yeah.
Can you do number 10?
Sure. Number 10 is the sphere is inscribed in a cube. I'm actually going to take the picture because that picture actually turned out pretty well. So if we look at 10, 10 says, a sphere is inscribed in a cube. If each side of the cube is 12 centimeters, what is the volume between the sphere and the cube? So I just need cube minus sphere, and that's that area that's in between. Well, the cube isn't going to be hard. Every side of a cube is 12. So it's 12 times 12 times 12. That's where I came up with the 12 cubed. In fact, that's where cube comes from, is because it's a cubed thing. All right, then I just need the volume of the sphere and subtract those. Well, volume of sphere is 4 over 3 pi r squared, right? Or cubed, I'm sorry, cubed. So we just need the radius of that sphere. Well, since it's inscribed in this, and since this distance is 12, that means half the distance would be 6. And half the distance from side to side would be my radius of my sphere. So we just need that 6 from there. Basically, that 12 is our diameter, right? Other questions? Okay, if there's no other questions for me, the rest of the time is yours to work. Make sure your homework is somewhere handy so I can check it. Tori, do you have a question on this, or is? About your calculator? Yeah, what's wrong with it?